Good morning to you all. Already we know that the poles, any one of the pole is on the right hand side of the S-plane, then the system is said to be unstable. We know. Already we have seen for first order, second order, up to third order we have seen. We know how to find the poles of first order, second order, up to third order. But beyond that, it's very difficult to find the roots of denominator, that is poles of the system. That's why it's difficult to say the location of poles. So there is a procedure to find the location of poles, whether it is on the right hand side or left hand side or on the j omega axis. For that, there is a criterion called Routh-Hurwitz criterion. Let us see that. Routh-Hurwitz criterion, some special cases are there. If you proceed the Routh-Hurwitz criterion, sometimes we may fail in the middle. There may be two reasons. One is the first column element may become 0 suddenly. If it becomes 0, you cannot proceed further because we have to divide by that number. You will get infinity. That's why you may not proceed further if first column element becomes 0. That is one difficulty. That is, we may have a 0 in the first column of a row. That is first difficulty. Second difficulty, sometimes may all elements in the entire row become 0. That is also possible. Then also not possible to proceed further. Let us see one by one. Let us see one by one. Let us now consider this sum. Example 3.5. Determine the stability of the system whose characteristic equation is this. That is, denominator polynomial of this system is this. So now we have to form the Routh array. What is the highest degree? S power 5. So we have to S power 5 and S power 4. 2 rows we can write. That is 1, 2, 3, 6, 5, 3. So in the first row we are writing 1, 3, 5. In the second row we are writing 2, 6 and 3. That's all. So first 2 rows we got. Now let us find S cube row. 2 multiplied by 3, you will get 6. That is Ath row, Bth row, Cth row. C1 equal to 6 minus 6 divided by 2. That is equal to 0. So you will get a 0. Then you see 2 multiplied by 5 minus 1 multiplied by 3. So what you will get? C2 equal to 2 10 minus 3 divided by 2. That is 7 by 3. 7 by 2. 7 by 2. So we cannot proceed further. You cannot find the S square row because we have to divide by this number. That's why we cannot proceed. Now, to proceed further, what we can do is, again, let us write the Cth row as, instead of 0, we will put epsilon. Epsilon and 7 by 2. So we are, in this case, epsilon tends to 0. Limiting case. That 0 is assumed as limiting case. Replace 0 by epsilon. That's all. Now we can proceed further. Now, what is dth row? That is a square row. Here, epsilon multiplied by 6. This we have to remove. So epsilon multiplied by 6. 6 epsilon minus 2 multiplied by 7 by 2. That is 7 divided by epsilon. 2 multiplied by 7 by 2, that is 6 epsilon minus 7 divided by epsilon. So s square. No further elements. Now we have to find the s power 1 row. S power 1. That is equal to, this is only one element. Here epsilon and 7 by 2 is there in this row. We have to use S3 row and S square row to find the S power 1. So each element we have to find. E1 equal to what? E1 equal to we have to multiply 6 epsilon minus 7 divided by epsilon multiplied by 7 by 2 minus epsilon multiplied by 0. Therefore 0 whole divided by 6 epsilon minus 7 divided by epsilon. You have to divide by this. That is equal to 7 by 2 only you will get. The same 7 by 2 you will get. Then s power 0 is what you will get. Here epsilon multiplied by one more element is there in s power 3. Epsilon multiplied by 3 minus 2 multiplied by 0. Therefore, you will get 3 here. 3 here. If you use this 7 by 2 and 3, you will get 3 here. You will get 3 here. So, what are the first column element? 1, 2, epsilon, then 6 epsilon minus 7 by epsilon, 7 by 2, 3. What are the first column elements? Let us write s power 5, s power 4, s power 3, s square, s power 1, s power 0. I am going to write only first column elements. 1, 2, epsilon, 6 epsilon minus 7 divided by epsilon. S power 1 is 7 by 2 and 3. Now let epsilon tends to 0, you apply, what you will get? S power 5 is 1, s power 4 is 2, s power 3 is 0, s power 2 is, if you apply 0, minus 7 by 0, therefore minus infinity. Here 7 by 2, s power 1 is 7 by 2, s power 0 is 3. How many sign changes? No sign change, no change, no change. Here one sign change, here one sign change, here no sign change, no change. Only 2 sign changes, 2 sign changes. Therefore 2 poles on the right hand side unstable. 2 poles on the right hand side and unstable. Now let us check in MATLAB. So roots, we have to enter the coefficients. The coefficients are 1, 2, 3, 6, 5, and 3. Only 2 roots have positive real part. Therefore, 2 roots on the right hand side. So what we found in Routh array is correct. 2 poles on the right hand side, therefore unstable.